Hello, my name is Nikopoulos. I am an undergraduate student at NTUA, and I will be presenting you my poster contribution to this conference titled Deciphering the Large Cometary Structure around the Planetary Nebula A66 that I did during my final year. Stars in their AGB phase eject most of their exterior material in the form of a strong, dense stellar wind. The contraction of that AGB core towards the formation of a white dwarf triggers a faster stellar wind that sweeps the previously ejected material, shaping the final morphology of the planetary nebula. Planetary nebulae can have different morphologies, one of which is a bow shock with a tail in the case the white dwarf is moving supersonically through the interstellar medium. Having observed and successfully analyzed the planetary nebula HFG1, which is depicted at the top left of the image right here, our group came across the planetary nebula A66, which is the black spherical bubble depicted right here at the bottom right of the image. We can see that this nebula is also surrounded by a possible bow-shaped cell expanding into this region, which is also followed by a long collimator tail. In this figure, we showcase all regions of interest towards analyzing this structure. We observed most of the designated areas, the red boxes, using high-resolution images captured from the 2.3-meter Aristarchos telescope at HelAS Observatory in Greece in the H-alpha plus and 2 and all 3 filters. The field of view of the high-resolution images is 5.5 arc-minutes in each dimension. For a better view of the preliminary results, we created mosaic images containing the wide field image as a base, combined with the high-resolution images we took from Aristarchos for every filter. In figure 2, we see the mosaic created for the H-alpha plus and 2 filter. We can see that both nebulae are visible here, and we can also observe a dense bow-shaped structure around the planetary nebula A66 with a significantly larger amount of radiation emerging from the southeastern part of it. The bow shock itself seems to be facing towards the southeast, indicating the direction of motion of the central star. Figure 3 in the middle depicts the all 3 filter mosaic. Both planetary nebulae are also visible in this filter, although we can see that the bow shock of HFG1 is much brighter than it was in the H-alpha plus and 2 filter. However, as observed, the cometary structure of A66 is fairly absent from the all 3 filter. Although this can be indicative of low shockwave expansion velocities smaller than 100 kilometers per second, more high-resolution images are scheduled to be obtained in the O3 filter in order for this issue to be clarified, whether it exists or not. Finally, the last image to the right is a mosaic of both the H-alpha plus and 2 and O3 wide field images used as a base with the H-alpha plus and 2 high-resolution images combined. In this image, we have increased the contrast so that we are be able to see fainter structures with greater detail. We can clearly see that the tails of the bow shocks of A66 and HFG1 seem to be intersecting in this part of the image right here. This indicates possible interaction between these two objects in the past. Considering the average of distances of A66 calculated by publications at 847 parsecs, the distance of the stagnation point to the white dwarf of A66 is measured to be about 3.8 parsecs, whereas the structure itself, the cometary structure, stretching all the way to the tail, is about 15 parsecs long. Continuing our current work, we will obtain high-resolution spectra in various positions in the vicinity of this planetary nebula, as well as calculate the distance of the A66 to Earth using the parallax method. We will also use hydrodynamical modeling in order to simulate the time-dependent evolution of the shockwave and the last stages of evolution of its progenitor star. Finally, we aim to examine the assumption that A66 and HFG1 probably interacted in the past, creating the aforementioned 2 structure visible in those mosaic images. So, thank you for your time, and I'm looking forward to discussing with you during the conference.